So, hello everyone. This will be the second part of our discussion on students' t-distribution, and we have here the properties of t-distribution. For the first one, the t-distribution is symmetrical about 0. That means if you draw a segment from the peak of the curve to the 0 mark on the horizontal line or horizontal axis, the curve is divided into two equal parts or areas. Also, the t-scores on the horizontal axis will be divided also into half of the t-scores, being positive and half negative. And as you can see here on our illustration, the t-distribution is symmetrical about 0. The other half is positive and the other half is negative. So the second part of the second properties of t-distribution is it is bell-shaped like the normal distribution. The only difference is it has heavier tails, meaning there are more areas on the tails. That means it is more prone to producing values that fall from the mean. The tails are asymptotic to the horizontal axis, meaning to say it approaches and approaches the x-axis but never touch it or never intersect the x-axis. This one is an illustration of what I am saying a while ago. Okay, it has heavier tails, meaning to say there is a lot of area here, also here. And as we have said on the previous video, it has lower peak than the normal distribution. We must also take note that similar to normal distribution, the mean, median, and mode of the t-distribution are all equal to 0. The variance is always greater than 1, unlike the normal distribution. It is equal to V, where V is the number of degrees of freedom divided by V minus 2. And as the number of degrees of freedom, or as the degrees of freedom increases and approaches infinity, the variance approaches 1. Using the formula, if the number of degrees of freedom is 10, the variance is, okay, 10 divided by 10 minus 2, and that will be equal to 10 over 8, which goes to show that will be 1.25. Also, as the degrees of freedom increase, the t-distribution curve looks more and more like the normal distribution. It gets higher and higher peak and lighter and lighter tails. With infinite degrees of freedom, t-distribution is the same as the normal distribution. This is what I'm saying a while ago. If you're going to take a look at t-distribution with 1 degrees of freedom, it has lower peak and higher or heavier tails. As the degrees of freedom increases, the more it look like the normal distribution. That's the fifth property tells us. So the sixth property is the standard deviation of the t-distribution varies with the sample size. It is also always greater than 1, unlike the normal distribution, which has a standard deviation of 1. And the total area under a t-distribution curve is 1 or 100%. It is similar to the normal distribution. One can say that the area under the t-distribution curve represents the probability or the percentage associated with the specific sets of t values. Moreover, the exact shape of t-distribution depends on the degrees of freedom. Remember that the lesser degrees of freedom, the lower is its peak and the thicker is its tails. And as the degrees of freedom increases, the tails or the tails become flatter and the peak becomes higher. So that means, given the area of the probability, the t-value depends on the number of degrees of freedom. For example, with the given area of 0.05 on the right tail of t-distribution, the t-value is 2.015. With 5 degrees of freedom, but with 20 degrees of freedom, the t-value is equal to 1.725. Now take a look at the next slide. As I have said here, if we have the degrees of freedom 5 and the area to the right is 0.05, the t-value is 2.015. But on the other hand, if the degrees of freedom is 20 and the area is 0.05, then we can see here that the value of t is 1.725. It is smaller, it gets smaller as the degrees of freedom increases.